Let us think about a line and a circle, right? In this particular diagram, there is a line and a circle, and these are not intersecting, right? Now, a line can intersect a circle at maximum 2 points. Maximum 2 points, right? Let us say this is the center, and this is a line which intersects the circle at two different points. Then this is known as secant for this circle. Now, if I draw another secant parallel to it, right, this also cuts the circle at two different points. But when I reach here and try and draw another secant touching the circle at this point, this will touch the circle exactly at this point, only one point, and it is not a secant anymore, it is tangent to this circle, right? When the line touches the circle at exactly one point, this is known as the tangent of this circle, right? So it is a special case of a secant, special case of a secant, or in other words, it is a limiting case of a secant. Why do I say this is a limiting case? Because look at this length here, this gap, let us say this is AB. So look at this line segment AB. If I go towards outside or away from the center, this segment which is intercepted between the circle and line is decreasing, right? It is decreasing as I go outside or away from the center, right? When I reach at this point, this gap vanishes. So this is the limiting case of a secant. Now this is a tangent, right? So I hope these you are comfortable with these words, tangent and secant. Tangent is a line that touches the circle at exactly one point. Now the point where the tangent touches the circle, let us say this is the point. Pardon my drawing. Let me draw another line. Yeah, this is a secant. This is a tangent, right? It touches at this point. Now let us name this point as P. This point is called point of contact, right? If I join this point of contact with the center of this circle, right? This is nothing but a radius of the circle, right? The angle between this radius and this tangent is going to be 90 degrees. Or in other words, the radius is perpendicular to the tangent drawn at the point of contact. Okay. Or in other words, you can say the tangent is perpendicular to the radius at this point of contact. All right. Now, how to prove it? You can prove it by contradiction, or you can understand it like this. Any point on this tangent apart from point P will lie outside the circle. Any point apart from this point P on the tangent will lie outside the circle, right? For example, if I talk about this point P1 here, this will lie outside the circle. If I try and join this with center O, then this segment OP1 has got two parts. One of these is up to this point, right? Now this much part is radius, right? And this segment, this part of the segment is extra. So what I mean to say is OP1 is greater than OP, right? This will be true for any other point apart from P which lies on this tangent, whether it is P2 or P3, because these all points are outside the circle. Hence, their distance from the center is going to be greater than the radius, right? So I can say that OP is the shortest distance. OP is the shortest distance between the center and the tangent, right? OP is the shortest distance between the tangent and the center. Hence I can say that OP is perpendicular to the tangent. Let us name it as L. So OP is perpendicular to L, because whenever I see the shortest distance between a point and any line, the shortest distance is the perpendicular distance of this point and this line. This is something that we know already, right? So this is one of the ways of looking at it. Another way can be that you consider that this is not 90 degrees for a moment, right? And you consider this angle to be 90 degrees, because then if it is not 90 degrees, then there has to be some other point where it will make an angle of 90 degrees with the radius. So let it be the 90 degrees angle. Now what you can use is, you can use the contradiction. How? Because if now this is 90 degrees, then the side opposite to it is the hypotenuse, and it has to be the largest side. But it is not true, because this side here is greater than the radius, right? Which we have already shown. Then your assumption that this angle is 90 degrees is wrong. So by using this contradiction, you can show that this is not going to be the 90 degrees angle. This is the angle that is going to be 90 degrees, right? This is how you can think about this. Now look at the next theorem. If two tangents are drawn to a circle from an exterior point, then the lengths of the tangents are equal. They subtend equal angles at the center. The angle between them is bisected by the straight line joining the point and the center. Okay. Now in this case, we have got a circle. We have got an exterior point. Let us say this point be P. Okay. If two tangents are drawn to a circle from an exterior point, let us draw these two circles. Let us draw these two tangents. One is PT1, let us say. Let us draw another tangent to this circle, and let us name it as PT2. Okay, so these T1 and T2 are points of contact. Okay, and let this be the center O. If I join this center O with T1 or T2, we know that this angle will be 90 degrees angle, because this is radius, this is tangent, and angle between the radius and tangent at the point of contact is 90 degrees. We just proved it in the previous theorem. So this angle is 90 degrees, this angle is also going to be 90 degrees. Now join O with P. Okay. Now once you have drawn this much, we can draw certain conclusions. Because if we look at these two triangles, this one and this one, that is OPT1 and OPT2. If you look at these two triangles, this line OP is a common side to both the triangles. OP is common to both the triangles, and OT1 is equal to OT2. You tell me the reason. OT1 is equal to OT2 because these are radii of the same circle, and this angle are equal, right? Because both are right angles. So in triangle OPT1, I can say OT1P, angle OT1P is equal to angle OT2P in this triangle, right? So by RHS congruence criterion, what can you say about these two triangles, OPT1 and OPT2? I can say that triangle OPT1 is congruent to triangle OPT2. And now that these two triangles are congruent, I can say that their corresponding parts are equal. That means OT1 is equal to OT2, that we already have. PT1 is equal to PT2. This is the conclusion that we can draw. That is PT2 is equal to PT1, because these are corresponding parts, right? You can see the correspondence from here also. Otherwise, from here you can see the correspondence, because these two sides, this and this one, are equal. So their opposite angles, that is this angle and this angle, are going to be equal, right? What can you say about other parts? If this is the side, if this angle and this angle are equal, these two angles are already equal, then the remaining angle are also equal, right? Because both the triangles, to satisfy that the sum of internal angles of a triangle is going to be equal to 180 degrees. If two angles are equal, the third angle is bound to be equal. So all three angles are equal, side opposite to beta are equal, that is pt1 is equal to pt2. So the lengths of the tangents are equal. Now they subtend equal angles at the center. That means we are talking about this angle beta. pt1 subtends this angle which is beta, and pt2 subtends this angle which is again beta. We have already proved the second part also. Now the third part, the angle between them is bisected by the straight line joining the point and the center. That is, this angle is being bisected by this line. This is also something that we have already proved through this congruence. Okay, once you prove that these two triangles are congruent, all these results are already proved. Okay, and one more thing that you can notice here, that sum of these two angles is 180 degrees because each of them is 90 degrees. So what will be the sum of alpha and beta? Alpha plus beta is 90 degrees, because in any of these two triangles you can see alpha plus beta plus this angle is 180. Alpha plus beta plus 90 degrees angle is 180. So sum of alpha and beta is 90. Alpha plus beta is 90. So what can you say about sum of these two angles, this angle and this complete angle? Sum of these two angles is 180, because this is nothing but twice of alpha and beta. Twice of alpha plus beta is going to be 180. So these two angles are supplementary to each other, this one and this one, right? Because these two are 90 degrees each. So we can say that these two angles are supplementary to each other. All right, let us look at the next one and cover it here itself. There are exactly two tangents from an exterior point to a given circle. Okay, let us say this is the circle that we are talking about. Okay, and let us take this as an exterior point. We need to prove that there can be only two tangents that can be drawn from this point to this circle. Okay, there can only be 2 points where we can draw the tangents from this point to this circle. Okay, let us join this exterior point with the center O. Okay, now look at this. If you draw one tangent, let us say this pt1. If you draw this pt1, what will happen is, if you join O with t1, then this angle is going to be 90 degrees, right? Let me change the color of the pen. This is going to be the 90 degrees angle or a right angle. Now you just think about this tangent. We do not think about this tangent for a moment. So when you draw pt1, ot1 and pt1 will have a right angle between them, which we have already proved in this lecture itself. Now if you consider op as your diameter, if you consider, first of all you should know that if you draw a circle and you've got any diameter, then this angle is going to be the 90 degrees angle. That is, angle in a semicircle is a right angle. Now if you take this OP as your diameter and try and draw a circle taking OP as diameter, then this point is going to be the part of the circle, because I have taken OP as the diameter, and this point, or we can say at T1, O T1P is 90 degrees, which is angle in a semicircle. So if I try and complete this circle, this will cut this circle at two different points. Let it be the second point where it cuts this circle, because two circles can cut each other at maximum 2 points if these are two different circles. Okay, so the circle with diameter OP cuts this circle at 2 points, one of which is this T1, where this tangent and this radius are perpendicular to each other. Now this circle cuts this circle at another point, which is this one. Let it be T2. Okay, so what can you say about this angle here? If you join this O with T2, what can you say about this angle? This is also going to be 90 degrees, because OP is a diameter and this is another angle made in the semicircle. For example, in this diagram, if you draw another angle on the other side of this circle, this will also be 90 degrees, right? So these two circles can cut at maximum 2 points, and the other point where it cuts the circle is T2, and here the angle is 90 degrees. Hence this PT2 is another tangent that can be drawn from this point P. So what is the property that I'm going to use? What I've used here is that two circles can intersect each other, two different circles can intersect each other at maximum 2 points, right? So this is what I've used. Another property that I've used is angle in a semicircle is a right angle, right? So let me just recap this. Let us say you have got a circle and an exterior point P. Okay, you draw a line touching this circle at one point, which you can easily draw, right? Let it be the point T1 and this be the center. If you join center with this exterior point P and with this point T1, this angle here will be a right angle. This is something that we have already learned. Now taking this OP as diameter, I can draw a circle. Now this circle will necessarily pass through T1, right? Why do I say that? Because this angle is 90 degrees. If I take any line as my diameter, okay, and draw a circle, this angle is going to be 90 degrees, right? If I take a line and let it be the right angle triangle, if I take this as my diameter and draw a circle, this will pass through this point, definitely. So this is what I'm using here. Now see, this circle is going to intersect this circle at this point and another point, which is this one, right? So if I join O with this point and P with this point, this angle will again be 90 degrees, because this is diameter of the circle and this is angle made in semicircle. So this is 90 degrees once again. And if it is 90 degrees, this is also an angle between radius and this line which touches this circle at only one point. So it is another tangent for this circle, right? So I have used these two properties to prove that there can be only two tangents drawn from an external point to a circle. Okay.